Hi, we're looking at functional skills maths from Pearson Edexcel level 2. We've got past paper 8 and we're going to start with the non-calculator section. Question 1. Eve buys lunch on her way to work. She sees this meal deal. We've got meal deal here. Buy any sandwich, snack and drink for £3.99. Eve chooses these items: chicken sandwich for £2.85, fruit snack pot 79p, and a coffee for £1.59. Work out how much money Eve will save using the meal deal. You must show you're working. So these are the individual prices. This is how much she's going to pay because she's buying them as part of the deal. So we want to work out the total of this and then take away the £3.99. So we're going to have £2.85, 79p, so we can write that as £0.79, and then we've got £1.59. So we're going to add them up using the column method. So 5 plus 9 is 14, add another 9 is 23. So we put the 3 and carry the 2. Then 8 plus 7 is 15, plus a 5 is 20, plus a 2 is 22. So 2 and carry the 2. Now we bring our decimal point down. Now we've got 2 plus 0 plus 1 is 3, plus the 2 we carried is 5. So the total cost, if we bought the items individually, would be £5.23. We want to know how much money Eve saved by using the meal deal price of £3.99. So we're going to do our £5.23 minus £3.99. Okay, so I'll say 3 take away 9. Well, we can't take 9 away from 3 because 9's bigger. So instead we can take 1 from the 2. So reduce that down to 1 and we make this 13. So 13 minus 9 is 4. Now we've got 1 minus 9. Well, again, 9's bigger than 1. So we're going to have to take 1 from the 5. So we reduce that down to 4. Pass 1 over. So now we've got 11 minus 9, which is 2. Bring the decimal point. And 4 minus 3 is 1. So we've got £1.24. Now there's another way you could have done this. If we want the difference between £3.99 and £5.23, you could say, well, £3.99 is just 1p away from £4. So if we took £4 off of this, well, 5 minus 4 would make it £1.23. But then we've got the extra penny to add on, which would make it £1.24. So you don't have to do the column method for the subtraction. Either way would work as long as we end up with the right answer of £1.24. Question 2. Work out 74.88 divided by 1.2. Okay. So I'm going to write this as a fraction because I think this might help us. So we're saying 74.88 divided by or over 1.2. Now, hopefully you're comfortable with sort of cancelling. If we had zeros top and bottom, we could cancel them. We're going to do the opposite. So we're going to increase both of these by a factor of 10. In other words, what I mean is we're moving the decimal point 1 on the top and 1 on the denominator as well, which means this is the same as 748.8 divided by 12. Or 748.8 divided by 12. So you see we've just moved the decimal point once on both. Okay, so it's not really done a massive change, but what it means is that when we do our bus stop method, so 748.8 divided by 12, we haven't got a decimal point getting in the way here. I just think it makes it a little bit tidier. So we say, okay, how many times does 12 go into 7? Well, 12's bigger than 7, so it doesn't go. So instead, how many times does 12 go into 74? So we use both numbers. Well, we got 12 24, 36, 48, 60, 72. 84 is going to be too many, so we're going to stop at 72. So that's 6 times. 73, 74, so that's 2 we've got left over. So how many times does 12 go into 28? Well, 12, 24, so that's twice. And then 25, 26, 27, 28, so 4 left over. We'll put our decimal point in. So how many times does 12 go into 48? Well, 12, 24, 36, 48. That's exactly 4 times. So we've got an answer of 62.4. Question 3. ABCD is a 4-sided shape. BD is a line of symmetry of the shape. Work out the value of x. Okay, so if we've got a line of symmetry, that means we've got a line on this shape where if you fold it in half, one side would exactly match on the other. So I think that we're going to have our line of symmetry down the middle. Okay, so that's going to match onto there. What that means is that this angle here must be the same as this one. So that must be x degrees. Okay, now you can do this in 2 ways. You can think, oh right, I've got a triangle here, and we can use that to work out x. Or we can think, well, if we've got a 4-sided shape, or a quadrilateral, another word for a 4-sided shape, then angles of 4-sided shape add up to 360 degrees. Okay, so we can say, well, let's add up the angles that we've got. So 108 and 49. 8 and 9 is 17, 7 carry the 1. 4 and 1 is 5, 1 and nothing is 1. Okay, so these two angles together make 157. So if we take these away from 360, we're going to be left with these two angles. So 360 minus 157. Well, 0 minus 7 we can't do, so reduce that to 5 and pass 1 over. 10 minus 7 gives us 3. 5 minus 5 is 0. 3 minus 1 is 2. So we've got 203. Okay, so 203 degrees left, and that is for these two angles. So we can say 203, we can use a little bit of algebra, it equals 2x, or 2 times x, because we've got 2 of them. So if we want just 1x, we want 203 divided by 2. Okay, so we're going to do bus stop method. 2 into 2 goes once. 2 into 0 doesn't go. 2 into 3 goes once with 1 remainder. So I'll put a point 0. So I've got somewhere to put my remainder. Put the decimal point up here. How many times does 2 go into 10? 2, 4, 6, 8, 10. That's 5 times. So we've got an answer of 101.5 degrees. If you wanted, you could have done this as, say, doing it with a triangle. So if we did it with a triangle, which way should we do it? Let's draw it this way. Okay. It doesn't have to be exact, I'm just doing it as a quick sketch. So if this is 108 degrees for all of it, well then this angle must be 108 divided by 2. Okay, so 2 into 1 doesn't go, 2 into 10 goes 5 times, and 2 into 8 goes 4 times. So we'd have 54 degrees here. We could do the same thing down at the bottom. This would be 49 divided by 2. 2 into 4 goes twice. 2 into 9, 2, 4, 6, 8. It's 4 times with 1 left over, so again we've got to do this to put our remainder. 2 into 10, 2, 4, 6, 8, 10. That's 5 times. So we've got this angle is 24.5. So we could then add these two together. So 54 plus 24.5. So we've got something to add the 0.5 to. We can put a 0.0 there. 0 and 5 is 5. Decimal point. 4 and 4 is 8. 5 and 2 is 7. So that's these two angles. So that means that this angle here, if we know the total angles in a triangle are 180, we want 180 minus 78.5. So we'll do a 0.0. So we've got something to take the 5 away from. Now we can't take 5 away from 0. So we need to get 1. We can't get a 1 from here. So we have to reduce the 8 to a 7. Pass 1 across. Then we can reduce the 10 to a 9. Pass 1 across. So 10 minus 5 is 5. Bring down the decimal point. 9 minus 8 is 1. 7 minus 7 is 0. And 1 minus nothing is 1. So we get exactly the same answer as we had over here. But this is our alternative method. So I'll do or. So whichever way you find simpler. I think a lot of people might find this method easy to understand because you're just working with one triangle for 180 degrees. This way you can do it. Just remember that for a four-sided shape, the angles are going to add up to 360 degrees. But then you're going to have two angles the same, so we need to make sure we divide it by 2. And then right down at the bottom, we've got to, actually we can write our answer in here, 101.5 degrees. And we've got use estimation to check your answer. Okay, well, with this one, if I do a quick sketch of this shape again, I've got 108 degrees there. That was X. That was 49. So we can say, well, 108 is approximately equal to 110 degrees, if we do to the nearest 10. And 49 degrees is approximately 50 degrees. So if we add these together, 0 plus 0 is 0. 1 plus 5 is 6. 1 plus nothing is 1. So we've got 160 degrees for these two angles. So then if we take that away from 360, which are the total angles in the shape, we get 0 minus 0 is 0, 6 minus 6 is 0, 3 minus 1 is 2. So we've got 200 degrees for these two angles. Remember that is also an X because it's the same, because we've got a line of symmetry. So then we would say, well, 200 divided by 2, 2 into 2 goes once, 2 into 0 goes 0 times, and 2 into 0 goes 0 times. So we've got an answer of 100 degrees, and we can say, well, that's approximately equal to 101.5 degrees. So that's our check right estimation. Okay. Then we've got question 4. Let's see if I can get... Oh, we won't be able to fit it all in. I'll have to move it up. Max is building a new shed. He has drawn this sketch. Very nice sketch he's drawn. Each shaded wall of the shed is in the shape of a trapezium. Okay, so these are the walls on the sides. Trapezium here with our parallel sides and the same one here. The other two walls are rectangular. So one here at the front and one at the back. Max wants to cover the 4 walls with wood cladding. he will not use any cladding for the floor or the roof. So we don't care about the bottom or the top. It's these two sides, the front and the back. He will buy the cladding in packs. Each pack of cladding covers 1.1 meters squared. Now let's move this up here. Okay. Let's do it here so we can see the question as well. The cladding can be cut and joined. Max knows that the two rectangular walls need 8.8 meters squared of cladding in total. Okay, so two rectangular walls. So this is the front and the back. And they've asked us work out how many packs of cladding Max needs to cover the four walls. Right, let's bring this back down a bit. Okay, so if we want to know how many packs of cladding we need to start off by working out the total area that we're going to need on the four walls. We've got the front and the back, so we need to work out the area of the sides. Well, these are going to be the same, so we just need to work out the area of one of these, and then we can double it and add it on to the area we've got for the front and back. Okay, so what I'm going to do, we've got this trapezium here, but I'm actually going to rotate the trapezium round because I think we're more used to seeing a trapezium something like this. So we've got our right angles here, where we've got our parallel sides at the top and the bottom. If you're comfortable with it this way, that's absolutely fine. So if we just add the measurements on here, this bit is 1.8 meters. This bottom bit is this length here, 2.6 meters. And the height, because we've now twisted it round, is actually this distance, so 3 meters. Now, the area of a trapezium is a half of A plus B, where A and B are the opposite parallel sides, and then we multiply it by the height. So in other words, we're going to want a half, and because it's next to it we've got times. Well, what's A plus B? Well, it's going to be 1.8 plus 2.6. 8 and 6 is 14. Bring the decimal down. 1 plus 2 is 3, plus the 1 is 4. So we're going to have a half times 4.4 times the height, which is 3. Okay. So now you've got to work out what's going to be the easiest way to multiply these together. So it doesn't matter which order we need to multiply these three together. Well, we want a half of something. I think it's going to be easier to work out the half of 4.4 because these are both even numbers. Okay, so let's do this up here. So a half of 4.4 is going to be 4.4 divided by 2. Half of something, you divide it by 2. 2 goes into 4, 2, 4. Oh, okay, anyway, that's twice. And 2 into 4 again is twice. So half times 4.4 is 2.2. Then we need to multiply that by the 3. So let's go back up here again for some space. Obviously, you would spread this out a lot more. I'm just trying to have it all on one sheet so you can see what I'm doing. Well, in fact, I'll put the decimal point in, but I'll ignore the decimal point for now. 3 times 2 is 6. 3 times 2 is another 6. We've got one decimal place here, so we put the decimal point back in. So the area of the trapezium is 6.6 meters squared. Okay, now I'm going to shift this all up. Right, so we want the total area. Well, we've got the front and the back are 8.8 meters squared. Then we've got one side, which is 6.6. Then we've got the other side, which is another 6.6. Okay, so 8.8, 6.6. 6.6, 6.6, and we're adding those all together. 8 plus 6 is 14. Add another 6 is 20. Same again, 8 plus 6 is 14, add another 6 is 20, but now we've got the carried 2, so we've got 22. So we've got a total of 22 meters squared. Okay, now we've got to divide that by the size of each pack, 1.1. So we want to say, how many times does 1.1 fit into 22? Or in other words, 22 divided by 1.1. Okay, so what we would do is we'd do our bus stop method, put the 22 inside, we'd put the 1.1 inside. Okay, now this can be a little bit awkward because we've got the decimal point. We can do something similar to what we did in one of the other questions where we say, well, I want to get rid of this decimal. So by getting rid of it, I'm going to move the decimal point over to the right to make it 11. And if I do the same thing on this number, well, my decimal point's here. If I move it over 1, I'm going to have to insert a 0. So in other words, what I'm saying is that 22 divided by 1.1 is the same as 220 divided by 11. Because we've just multiplied them both by 10. Now this might be a bit nicer for us, because we're going to have 11 into 220. Well, how many times does 11 go into 20? Well, 11 doesn't go into 2. So what about 11 into 22? Well, 11, 22. So it goes twice. 11 into 0 doesn't go. So we're going to need 20 packs. And that's the end of the non-calculator section. So now we're on to the calculator section. Okay, question 1. Mandy spins a fair spinner twice. The colours on the spinner are red, blue, green, orange and pink. The table shows all the possible outcomes. So we've got red, blue, green, orange, pink along here, and red, blue, orange, or red, blue, green, orange, pink down here. So all the outcomes, so in other words, you could get red with the first spinner and red with the second spinner. Or you could get red with the first spinner and blue with the second spinner. And all of these combinations. Okay, so you could get the same colour, red and red, blue and blue, green and green, or you could get any other combination as well. Okay, some of these look like they might be repeated because you could get pink on the first spinner and blue on the second, or you could get blue on the first and pink on the second. But they're different results because it depends if it's first or second. What is the probability of getting the same colour on both spins? Right, well, let's start off by thinking, well, how many different results could we get altogether? Well, it's going to be all of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So 25 possible outcomes. How many of them have got the same colour? Well, red and red, blue and blue, green and green, orange and orange, pink and pink. So 5 possible answers. So 5 out of 25. You could simplify this down. So you could say, well, 5 goes into 5 once and 5 goes into 25 5 times. But they haven't asked us to simplify it and it's just 1 mark. So I'd probably just leave it as 5 over 25. But either of these would give you your mark. Then we've got part B. What is the probability? What's the probability of getting at least 1 blue in the 2 spins? Well, again, it's going to be 25 because there's 25 possible outcomes. How many of them have got at least 1 blue? Well, let's just work our way across and count them. Well, there's 1, 2, 3, 4, 5, 6. So they've got a B in them. Right here. This one, none of these. This one, none of these. This one here. So you'll see it's where all the blues are here and all the blues here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of 25. Okay. Question 2. Habiba wants to make pastry by mixing butter and flour. She needs to mix the butter and the flour in the ratio 4:9. Habiba wants to make 650 grams of pastry. She has 425 grams of flour. Does Habiba have enough flour to make 650 grams of pastry? Show why you think this. Right, so ratio question, so I'm going to draw my ratio table. So what I mean by that is just a nice simple table like this. And I'm going to put, well, we've got butter and flour, so we can put butter, flour, or you can put just B and F. And we're going to have a total column. And the ratio of butter to flour is 4:9. If we only had 4 of butter and 9 of flour, our total would be 4 plus 9. We can use our calculator now, which gives us 13. Okay. In fact, Habiba wants to make 650 grams. So we want this to be our total. Okay. So we can use this to work out how much butter and flour we would need. Well, how do we get from 13 to 650? Well, we've got to work backwards. So we've got to think 650 divided by 13. We get 50. So to know how much butter and flour we need, we're going to multiply each of these by 50. So 50 times 4 gives us 200. And 50 times 9 gives us 450. And we can check that 200 plus 450 gives us 650. So she wants to make 650 grams of pastry. She has 425 grams of flour. Does she have enough? Well, no, she needs 450. So 425 is less than 450. So no, she does not have enough flour. Question 3. Habiba also wants to make cupcakes. She has this list of ingredients. So cupcakes makes 12. So you need 2 cups of flour, 1 egg, 3 tablespoons of butter, 10.5 or 10.5 fluid ounces of milk. And remember with these, if you don't know what full Oz means, it doesn't matter, it's just a measurement. Same with tubspa. It means tablespoons, but we don't care, it doesn't matter. So don't worry if you see something you're not sure about, it's just a unit, okay? It's the numbers that are important on these ones. So 3/4 of a cup of sugar, 3 apples, and a pinch of cinnamon. Habiba wants to make 30 cupcakes. We're told that 1 fluid ounce equals 28.413 millilitres. How much milk does Habiba need to make 30 cupcakes? Give your answer to the nearest milliliter. So we've got all of these measurements, but actually the only one we really care about is the milk. Okay, so we've also got this written as fluid ounces for 12 cupcakes. We want our answer in millilitres, but for 30 cupcakes. So what I think I'll do first is I'm going to convert this into millilitres to get the same units. So we're going to multiply this by 28.413. 10.5 times 28.413, and we get 298.3365. Okay. Now, that's for 12 cupcakes. We want 30 cupcakes. Well, if we want 30, what we can do to start off with is divide it by 12. That'll tell us how much we need for one cupcake. Okay, so we've still got this in my calculator. So note I've not rounded it. I've kept everything in the calculator. Divide it by 12. So that is going to be 24.86. And that's for one cupcake. We want 30, so we want to multiply this by 30. So I wrote it down to 2 decimal places on here, but I've not changed it on my calculator. I've still kept all the decimal places. So now we multiply that by 30, and we get 745. I'll do it to 2 decimal places for now. Millilitres. They want it to the nearest milliliter, so we round this to the nearest whole number. So 745.8. Well, this is more than 5, so we're going to round it up to 746 millilitres. So sugar, butter, flour, cinnamon, apples, egg. Didn't need it at all. Okay, so it's being able to find the key information and not get distracted by what we don't need. Question 4. Callum is a plumber. He spends money on 8 different adverts. Callum has this information about the money he spent on each advert and the number of new customers from seeing that advert. So we've got the amount of money he spent, the number of new customers. So for example, he spent £100 on this advert and got an extra 7 new customers. Let's pick one. This one, he spent £325 on this advert and he got an extra 23 new customers. Callum wants to draw a diagram to see if there is a relationship between the money he spent on each advert and the number of new customers from seeing that advert. Draw a suitable diagram for Callum. Right, so if we're talking about relationships, you should be thinking scattered graph or scatter diagram. So, it doesn't matter which one we do each way, but normally it's best to just take the first one we've got and to put it on the x-axis. So that's going to go down at the bottom. So we've got money spent, and the biggest value we've got is 325. So we're going to have, if we start our graph here, we're going to have money spent. That's going to be in pounds. And we had a value of 325. Well, we can probably say, if this is 0 here, we could have 100, 200, 300, 400. Yeah, I think that would fit on nicely. You want to try and use at least half of the graph paper you've got. So if we'd used down the bottom corner, maybe we could have spread it out more, but this is going to fit on nicely here. So we've got our money spent going along the bottom there. And then we've got number of new customers. Well, what's the biggest number we've got? Well, that's 23. So we want to think about how can we spread this up here. We could just go 10, 20, but then the graph's going to be very small. So maybe we spread it out a bit more and say, well, what if we had 2 big boxes for each 10? So we could say 10, 20, another 2 boxes would take us up to 30. We need to go at least as high as the biggest value, which was 23. So let's move it down to, you can see the 30 up there. And this was new customers. Okay, we've just got to remember now that because we put 2 boxes in for each 10, that each of these little boxes isn't going to be worth 1 anymore because we put 2 boxes. Each of these little boxes, or is each we're going to need 2 boxes for each one new customer. So it'd be like 1, 2, 3, 4, 5. You don't need to write these on, I'm just doing it to show you so you get an idea of how it would work. So now we need to plot our values. So the first one we've got for money spent is we've got £100 and 7 new customers. So 100, well this is 5, 6, 7. Then the next value we've got £175 for 12 new customers. Well, this would be 110, 20, 30, 40, 50, 60, 70, 80. So 175 is going to be in the middle. We want to go up to 12 customers. Well, that's 10. And remember, we need 2 little squares for each new customer. So 11, 12. So we're going to have that in there. Then we've got £80 spent for 4 new customers. Well, here's 100, so let's count backwards. 90, 80. So £80 for 4 new customers there. £250, so it's going to be halfway between 200 and 300. And we had 16 new customers, so this is 10. This will be 15, halfway in between. Up another 2 to get to 16. Then we've got £150 for 8 new customers. So 150 here. We go up to, this is 5, 6, 7, 8. Then we've got £325 for 23 new customers. Well, halfway between 300 and 400 will be 350. So if we want 325, 310, 320, 325 is going to be halfway between here and here. So let's take this up, and we want to get to 23. Well, that's 20, 21, 22, 23. Then we got £125 for 9 new customers. So 100, 110, 120, 125 again is going to be in between. Well, this is 10 new customers here, so we go down 2 boxes to get to 9. And finally, we've got £290 for 18 new customers. Well, this is 300, so 290 would be 1 box down. And 18 new customers. Well, this is 15, because it's halfway between 10 and 20. So 16, 17, 18 would go there. Okay. They haven't asked for it, but I think it's nice to draw a line of best fit as well. So that's the line that follows the general pattern of the graph with roughly the same number of values above the graph as below it. Okay, so we've got the line of best fit as well. And we just need a title. So what should we call this? Scattergram of money spent to new customers. Something like that. Okay. Question 5. Misha rows in a team of 8 people. She wants to compare the mean BMI of the people in the rowing team with the mean BMI of women in the UK. Misha uses this formula to calculate her BMI. So this is another one where if you don't know what BMI is, doesn't matter. They've given us a formula for working it out. So I'm not even going to mention what it is because it's irrelevant, okay? If you do know, excellent, but you don't need to know what it is. So we've got BMI equals W over or divided by H squared, where W is weight in kilograms and H is height in meters. Misha has a weight of 73.3 kilograms and a height of 67 inches. 1 inch is equal to 2.54 centimeters. We've got the table shows some information about the BMIs of the people in the rowing team. So Louise, Katya, Layla, and what their BMIs are. And Misha, and we're missing a value. The mean BMI of women in the UK is 26.9. Compare the mean BMI of the people in the rowing team with the mean BMI of women in the UK. Right, so we need to work out the mean BMI of this rowing team here. Okay, before we work out the mean, we need to know what this value is that's missing. So we need to work out Misha's BMI. Okay, so let's do this up here. So Misha BMI, well, it's the weight, and we're told the weight is 73.3 divided by h squared. But they want h in meters. Okay, we've got 67 inches. If we want to turn it into centimeters, we can multiply this by 2.54. So that gives us 170.18 centimetres. Okay, we want it in metres though. Well, I know that we've got 100 centimetres in a metre. So that means we want to divide this by 100. Okay. And that gives us 1.7018 metres. Now, all of the values in the table so far have been rounded to one decimal place. So we'll do the same here. So oh no, sorry, that's the BMI, isn't it? No, so we're going to keep this. So we want 1.7018, but that needs to be squared. Okay. Well, squared means multiplying it by itself. So I'm going to put this in our... No, what I'll do, so we've got this kept here already. We're going to multiply it by 1.7018. Okay, so that's our answer for the bottom. Now, instead of writing out all the decimal places, I'm going to put it in my memory plus. You can write it down. In fact, I'll do it in... So we've got 73.3 still, and we're dividing it by 2.896, blah, blah, blah. But because I put it in my memory, all I need to do is say, well, we've got 73.3 divided by memory recall gives us 25.3096. And this time, because it's a BMI, we're going to round it to one decimal place. So to one decimal place, it's going to be 25.30, or 0 is less than 5. So we can just do it 25.3. Okay, so we've got the BMI. Now we needed to work out the mean BMI of the rowing team. So the mean is the total divided by how many, or we can call it the frequency. So we need to add these all together. So we've got 24.8 plus 27.1 plus 25.7 plus 28.3 plus 26.4 plus 25.2 plus 27.6 plus 25.3 gives us a total of 210.4. And we want to divide that by the frequency. Well, we've got 1, 2, 3, 4, 5, 6, 7, 8. So 210.4 divided by 8 gives us 26.3. Right, so this is the mean BMI of the team. Compare the mean BMI of the people in the rowing team with the mean BMI of the women in the UK. So we've got 26.3 is less than 26.9. Or if we want to do it in words, we can say mean BMI of the people in the rowing team, and I'll put in brackets 26.3 is less than the mean BMI of women in the UK, which is 26.9. Okay. Question 6. Write 3,675,000 in figures. Well, they've helped us a bit by putting the commas in. Well, one comma here anyway. So we've got 3,675,000. 675,000. And we haven't got any hundreds or tens or units, so it's just going to be 0, 0, 0. Okay, part B. Let's do it up here. Okay, write 760 grams as a fraction of 1 kilogram. Write your answer in its simplest form. Well, 1 kilogram is 1,000 grams. So 760 grams as a fraction of that is going to be 760 over 1,000. Okay, that would get you a mark, but they want it in its simplest form, so that's to get the next mark. Well, we can cancel a 0 on top and bottom. So in other words, we've got 76 over 100 over 100. These are both even numbers, so let's divide them both by 2. Well, 76 divided by 2 is 38, and 100 divided by 2 is 50. Well, they're still both even numbers, so let's divide by 2 again. Well, we've already got 50 there, so let's divide the 50 by 2. 25, and 38 divided by 2 is 19. Okay, so we haven't got any more evens. Is there anything else we can divide them by? Well, 3. 3's not going to go into there. We can check with the calculator. 19 divided by 3 doesn't work. You can keep trying, or you can say, well, I know that 19 is a prime number, so we're not going to be able to simplify that any further. Okay, but if you're not sure, just keep trying with the calculator, see if you can get any numbers to go into the 19, and hopefully you'll exhaust them and realise that's as far as you can get. Question 7. Niam looks at the screen time report on his phone. This week, his average screen time per day is 28% greater than his average screen time per day last week. This week, Niam's average screen time per day is 3 hours and 44 minutes. Work out Niam's average screen time per day for last week. Right, well, we've got hours and minutes here, so it's not nice to have a combination of units. Let's turn this all into minutes. Well, 3 hours, I know we've got 60 minutes in an hour, so we're going to do 3 times 60, and then if we add on the 44, we'll get the total number of minutes. So 3 times 60 is 180, add 44, we've got 224 minutes. Okay, so, right, what we're saying is we've got 224 minutes, and that is 28% more than last week. So if you think 28% more, that's the same as saying 128% of last week. Okay. We want to work out the average screen time per day last week, so we want to find out what 100% was. Okay, so the way we can do that is say, well, 224, if we divide it by 100, that'll tell me what 1% is. Sorry, not 100. Yeah, ignore that. 224 minutes is for 128%. So if we divide it by 128, it'll tell us what 1% is equal to. So if we want 100%, we then need to multiply that by 100. Okay? Because 224 has already had the increase applied to it. So if we do 224 divided by 128, we're saying that 1% is equal to 1.75 minutes. Multiply it by 100, and we get 175 minutes. Okay. Now, when we started, they gave us the time in hours and minutes. So I'm going to turn this back into hours and minutes. Well, let's take off 60 minutes or 1 hour. That leaves us with 150 minutes. So I think we can take off another hour as well. Leaves 55 minutes. So basically what we're saying is that's 1 hour, that's another hour. So 175 minutes, which is equal to 2 hours and 55 minutes. Question 8. Frank wants to fit underfloor heating in his kitchen. The kitchen is in the shape of a rectangle. This is the big kitchen here. He has this sketch. So we've got 600 millimeters here. This whole thing is 4.5 meters. This is the floor space. This measurement is 3.6 meters. And we're told that the shaded space shows the part of the floor covered by cabinet bases. So these are all the cabinets here. And each cabinet has a depth of 600 millimeters, as shown on the diagram. Frank will cover part of the floor space with heating cable. Let's move this up. Okay. Frank needs to leave a gap of 100 millimeters between the base of the cabinets and the part of the floor space he will cover. So in other words, there's going to be a little gap here. Yeah. And that little gap there, if we can draw it on, they've told us is 100 millimeters. So it goes all the way around. Okay. He needs to buy a cable pack. The table shows information about the different sizes of heating cable packs and the maximum floor area each pack can cover. So we've got that down here. So we've got a small, a medium, a large, or an extra large. This is the maximum floor area it will cover for each one, and this is the cost of each one. Frank wants to spend as little as possible. Okay, we need the actual question. So let's find the question, which is: work out the cost of the cable pack Frank needs to buy. You must show your working. Right, so for us to work out the cost, we need to know the maximum floor area. Okay, and that's what we need this diagram for. Now we've got measurements here. Some of them are in meters, some are in millimeters. We want to sort of even these all up. So, what should we do? Maybe try, the maximum floor area on here is in meters squared. So maybe if we try and convert our millimeters up into meters. Well, I know we've got 10 millimeters in 1 centimetre. And then we've got 100 centimetres in 1 metre. So if we start off with this 600, if we divide it by 10, we're going to get 60 centimetres. And then if we divide the 60 by 100, and we'll do it with the calculator because we can, we get 0.6 of a metre. Okay, so this is 0.6 meters. And that's going to be the same all the way around. Okay. And the reason we're working these out is because we're interested in this floor space in the middle. So we want to take away these measurements to find out what this rectangle is. Okay. So we've got the grey bit, but remember we've got this narrow channel up here as well, which is where he's going to lay, what was that? That was the space he needs between the heated floor and the cabinet bases. And we're told that's 100 millimeters. So again, 100 millimeters, if we divide that by 10, we're going to get 10 centimeters. And if we divide it by 100, 10 divided by 100, we're going to get 0.1 meter. So this little bit is 0.1 meter, and we've got another 0.1 meter. So if we want to work out this measurement here, well, it's going to be the full 3.6, but we've got to take off 0.6 here. We've then got to take off 0.1 for this bit. Then we've got another 0.1 to take off on that side, and then another 0.6 to take off on that side, which I haven't left myself much space, but if we do that, 3.6 minus 0.6 minus 0.1 minus another 0.1 and minus 0.6, we get 2.2 meters for that measurement. Okay. We also want to work out this measurement, because if we want the area of the floor space, we need length times width. So we've got the width, we need the length. Well, this length, we know in total it's 4.5 meters. Well, going up, we can go all the way up. We need to take off 0.1 and 0.6. Yeah, because we haven't got both sides like we had when we were going this way. We've just got one of each. So 4.5 minus 0.1 minus 0.6, we get 3.8 meters. So that should then mean we can work out our area here. So we're going to have area of, well, it's not, I suppose it's the floor space, but it's not including that gap there. So I'll put area of usable floor space. So it's going to be our 2.2 times our 3.8. We've already got 3.8 in there, times 2.2 gives us 8.36 meters squared. Okay, so we now look at our chart. He wants the cheapest cable, but it's got to be bigger than what we've got. So 8.36 meters squared. Well, the small's not big enough. The medium's not big enough. 8.4. Well, yeah, that is greater than 8.36. So this one's fine. So we want the large pack, and it's going to cost £179.99. It can get a little bit messy on here, so what you might want to do is draw your own, a new little sketch with your diagram, with your 2.2 and 3.8, something like that. If it just helps, because you can get a lot of distractions on here. But essentially this is what we've done, and we've worked out the area of this one and then compared it with the values in the table to find the cable pack we need and the cost of that pack. Question 9. Sammy has designed a sweet tin in the shape of a cylinder. The plan and the front elevation of the tin are shown on the centimetre grid below. And the question is, find the volume of the sweet tin. Well, I'm going to draw, if it's a cylinder, the plan is a circle, so it's going to be something like that. Okay, just a sketch, just so we can get a feel for what it's going to look like. And if we want the volume, well, the volume, if we've got the same shape going all the way through, we're going to have a circle on top, and I'm just drawing the centre of the circle, and this is a radius. So we're going to want the area of the circle multiplied by the height of the cylinder. Okay. Well, let's start off by working out what's the radius of this circle. Well, the radius is the centre point, or the distance from the centre to the edge. So in other words, something like that. It could be anywhere on the circle. I could have drawn it here, here, here. But I've done it here because we know that this is a centimetre grid, this paper. So we can just count 1, 2, 3. So 3 centimetres. Okay. Now, the area of the circle, this is where you need to know your formula, is pi r squared. And pi, if you look on the front of the paper, it will tell you that for pi you can use 3.14. Radius squared, so it's next to r, so it means you multiply it by the radius, which is 3, and it's squared, so you multiply it by itself again. So we've got 3.14 times 3 times 3. So 28.26 centimetres squared. Okay. And we need to multiply that by the height of the cylinder. So we don't really care about this width here, we only want the height. So we've got, so let's just use this to show what measurement we're taking. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So we want to multiply the 28.26 by the 8. If you had a cuboid, you would do the height times the width times the depth. And it's the same sort of thing here, only when we're doing the length times the depth or length times the width, we're working at the area of that flat surface, that circle, and then we're multiplying it by the height. So 28.26 multiplied by the 8 gives us 226.08, and its volume, so it's going to be centimetres cubed. Question 10. Write 15 divided by 7 as a mixed number. Okay, so the mixed number means, well, at the moment it's an improper fraction, so the number on top is bigger than the one below. So we say, well, it's really 15 divided by 7. I mean, you can do this using your calculator, but I think it's simpler just to say this way. How many times does 7 go into 15? 7, 14, so that's twice. And how many left over? Well, from 14 to 15, it's just 1. So 2 remainder 1, or 2 and 1/7. Okay, part B. Here is a list of numbers. Find the median. Okay, well, best way to find the median is to rank them, so put them from smallest to largest. In this case, smallest is going to be the most negative. So we'll have -5 first. Then what's the next smallest? -3. Then 0. Then 4. Another 4. And finally the 6. So for the median, we cross off the smallest and the largest. And we keep doing it in pairs till we're left with either 1 in the middle or 2 in the middle, because it's an even number of values. So we need to add them together and divide by 2. So 0 plus 4 is 4, divided by 2, and we get 2. Then we're on to question 11. So we've got write 28% as a decimal. Well, 28% is just 28 out of 100, or 28 divided by 100. We've got our calculator to help us. If you're able to do this, that's great. If not, it's nice and easy with a calculator. 0.28. Andrew pays 38.90 euros for a meal in Spain using his British bank card. The British bank charges a fee for changing currency. The fee is 2.75% of the amount he pays for the meal. Okay, and we're told that £1 equals 1.127 euros. Work out the total amount Andrew pays for the meal and the fee. Give your answer in pounds. Okay, so you've got a choice how you do it. You can convert this amount into pounds and then increase it or add on the fee. I'm going to do the fee. I'm going to keep it in euros for now. So I'm going to say we want 2.75%. So 2.75 out of 100, and it's 2.75% of this, so we're going to multiply it by the 38.9. So 2.75 divided by 100, so that gives our answer as a decimal. Multiply it by 38.9, and it gives us 1.06975. So that is the fee. Okay. Now, because it's increased by that amount, we then want to add on 38.9. So I'm not going to round it yet. I'm just going to add on the 38.9. And we've got a total of 39. Let's write out all the decimals for now. Okay, and that's in euros. Okay. We want the answer in pounds. Well, this is the amount of euros. Pounds is less than euros, so we're going to need to divide it by the 1.127. So it can be difficult to know, do I multiply it, do I divide it? But if you think pounds are less than euros, so if we multiply by that, the number's going to get bigger. If we want it smaller, we've got to divide. So we keep the number in our calculator, divide it by 1.127. We get 35.465616. But of course this is money, so we're going to round it to 2 decimal places. So we 46. The next digit is, if it's 5 or more, we round up. So it's going to be £35.47. Okay, so now we should be on to the last question of the paper. Bilal works for a supermarket. His usual pay is £8.70 per hour. Bilal will work for 7.5 hours this Sunday. The supermarket will pay Bilal time and a half for working on a Sunday. Bilal thinks the supermarket will pay him more than £100 for working this Sunday. Is he correct? Okay, so he gets £8.70. He's working for 7.5 hours, so we're going to multiply that by 7.5. Okay, let's do this bit on its own first of all. Okay, so we get £65.25. That's before he gets the extra time and a half. Well, you think the time and a half is effectively multiplying it by 1.5 or adding on an extra 50%. So you could work out half of this and add it on, I'm just going to do it all in one step. So time and a half. So we've got the 1, we've got the original amount, and we're increasing it by half. So multiply that by 1.5, and we get 97.875. Again, this is money, so we're going to round it to 2 decimal places. So it's going to be £97.87, but if it's 5 or more, we round it up to 88. Okay, well, £97.88 is less than 100. He thinks it will pay him more than 100, so is he correct? No. He is incorrect. Now we've got part B of this question as well. Mina works in a different shop. The table shows some information about the wages for Bilal and the wages for Mina for the last 6 weeks. Okay, so Bilal, we've got the 6 weeks. Mina, we've got 6 weeks here. Bilal says, my wages were more consistent than Mina's wages for the last 6 weeks. Were Bilal's wages more consistent than Mina's wages? Give a reason for your answer. Well, consistency is talking about how much they go, how much they move, so how much they go up or down. Okay, so if we want to work out consistency, we want to work out the range. And the way we work out the range is we take the biggest and take away the smallest. So for Bilal, what's the biggest value? 283 is bigger than 216. Anything bigger than that? No, so that's the biggest. What's the smallest? 192 is smaller than that. 186 is smallest. So for Bilal, we want 283.94 minus £186.32. Oh no, 283.94 minus 186.32, and we've got £97.62p. For Mina, we want to do the same thing. What's the biggest value? She's got one in the 300s, so that's the biggest. And what's her smallest? 188, 126. So we want £308.71 minus the smallest, that was 126.40. So 308.71 minus £126.40, and we've got £182.31. Okay, were Bilal's wages more consistent than Mina's? So did they move by less than Mina's? Well, yes. Bilal had a range of 97.62, but Mina had a bigger range of £182.31. Okay, so we can say so Bilal's wages were more consistent. And that's the end of the paper. So I hope you liked it. Please like with a thumbs up. Subscribe if you haven't already. Make sure your notifications are turned on so you find out when I upload more videos. Put any comments you've got, and I look forward to seeing you all again soon. Thank you.